Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And guys, today we are going to get started with the concept and problem session, lecture number 4 on gravitation. So yes, do not forget to like this video and do not forget to share this video. Do not forget to call your friends on this video because it's going to be very interesting. We are going to discuss all problems, but along with each of these problems, we'll be also discussing. And what are we going to do in today's lecture? In today's lecture, we are going to get started with one of the most important topics, that is field, and we'll be also discussing distributed masses problem, or the concept of distributed. How do you calculate a gravitational field between distributed? Alright, let's get into the lecture. And for students who don't know me, I'm Muralidharan. I completed my MS in Electrical Engineering from one of the top ranking American university. I'm also an IIT who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. I filed 25 technology-based patent applications in. And guys, if you're not yet on our Telegram channel, do quickly get onto our Telegram channel. First of all, you need to download Telegram app from your Google Play Store and App Store and click on to this link which is available in the description box below. So what do you get by clicking on this link? You will get before time live updates of every class conducted by me or our awesome JEE English team. We are a bunch of IITians and IITians, and we also have a head of institution, head of a department on our team. So do get onto it, do not miss it out. This is where you'll get all the updates on time. And yes, also do subscribe to this channel so that you get timely notifications. Don't just click on that subscribe, but also on the bell notification to get the notifications, and do not forget to share this video, guys. Okay. And this Sunday from 10 a.m. to 2:30 p.m. We will be discussing vectors. Okay, so for many of you are going to get started over here. Do attend it and do try to solve many problems around them. What we'll do is we'll not take vectors just purely as a mathematical vector topic, but we'll take it from the physics perspective. We'll be also covering mechanics based problem on Unacademy learning app. Again, it's a free of cost special class, and do attend it, do not miss it out. And also on Monday we'll be having a lecture following this. Right, and guys, the units, dimensions and measurements has already been completed on Unacademy learning app. So again, these are like free of cost lectures available for your JEE Mains and JEE Advanced preparation. And what do we have on units, dimensions and measurements? We have covered everything, guys. Complete syllabus, in fact with some additional problems in only 5 sessions. Like, okay, what you see over here is 4 sessions. There would be another session like a model problem session which you need to attend, and your preparation on units, dimensions and measurements will be complete. You have done units based problem, dimension analysis of many different kind of physical quantities, both from the perspective of 2021 and 2022. So yes, 2022 aspirants, do not worry about it. Dimension analysis has been covered in such a way that I'm giving you, the objective was that I'm giving you introduction to each and every quantity along with the concept. Be sure to attend that, and of course error analysis is a very important part, and least count analysis, and definitely also measuring instruments like vernier calipers and this thing, vernier calipers and screw gauge. And guys, this is one of the topics which is definitely asked in your JEE Mains and JEE Advanced. So one is going to be, of course, your gravitation, one is going to be electrostatics, current and electricity. Same way, units and dimensions are asked regularly, not regularly but definitely, and you definitely get one question every year. And let me tell you, if you attend today's PYQ session, right, you will understand the importance of use the dimension methods. So what I'm going to do is we will be solving some JEE Mains problem just based on dimension. So be sure to attend that session as well. And but that being said, this as an individual topic is also asked apart from your questions. Is also directly asked in JEE Mains. Definitely one question. The error analysis is one of the parts which is frequently asked in your JEE Advanced, so in a combination. So definitely do attend it. Not only the easiest topic during your preparation, it's also less time consuming, and also during your exam it is less time consuming, and it is easy also during your exam. So be sure to attend it. And guys, if you don't have an Unacademy learning app yet, do download it. Type in Unacademy on your Google Play Store and App Store. The first search result is going to be Unacademy learning app, and then click on this install button. And why do you have to download Unacademy Learning App? There are thousands of reasons why you want to download Unacademy Learning App, but let me say, let me give you the best reasons. When you start following me, you will get live updates on every A to Z series sessions that I conduct on Unacademy Learning App. So I keep conducting A to Z sessions with PYQs, with a lot of PYQs and with a lot of different kind of model problems, with a lot of like a complete revision session, a complete thing where you can actually start even attending from the beginning. But for many of it might be a revision lecture. So yes, do install it and follow me so that you can get live notifications. Another thing is you can attend classes from it. You can attend national level quizzes. For an example, we do have quizzes every now and then. You can attend them from your Unacademy Learning app. Not only that, guys, more importantly, also attend Unacademy format, the most gamified event for your JEE. It's going to be like a battle, except that's going to be a gamified event. Of course, be sure. And that being said, students, if you're looking for the best in class program for your JEE Mains and JEE Advanced preparation, it's going to be on Unacademy subscription. So what do we have on Unacademy subscription? We have live classes. We give you live classes where you can interact with the best educators across the nation. Yes, on Unacademy subscription platform, we have aggregated all the best educators. And this platform would also be interesting. This would come with polls and leaderboards. The moment you start attending it, it's not going to be a regular platform, but you start enjoying, you'll learn. And guys, it comes with a lot of test series and analysis, and this way you will be able to analyze your performance and understand your overall performance and improve upon it. And students, of course, the program is a structured program. In every program, you will be having live doubt clearing session. And this live doubt clearing session is in a structured manner. Every fourth session is going to be a live doubt clearing session, so that you are able to maintain completeness on each and every subtopic that has been completed. And also it comes with quizzes and mega quizzes. So yeah, the best thing that you can have for your JEE Mains and JEE Advanced preparation could be your Unacademy subscription. Not only that, just don't have the best educators across the nation, have legends like DC on this. And guys, how do you avail this Unacademy subscription? All you need to do is click on the left hand top corner extension, choose plus, choose IIT JEE as a goal, and then hit on this get. And the other beauty is we have programs for both JEE Mains and JEE Advanced preparation. And let me tell you guys, it's only one subscription, unlimited access throughout the period. You can access as many programs as you want. You can both attend IIT JEE Mains and IIT JEE Advanced program, and even the batches as you like, batches not on Unacademy subscription. And guys, this all comes at a price of 2,100, less than 70 rupees a day is what you have to pay for Unacademy subscription platform. And students, of course, this is a 24-month program typically recommended for 8 to 11th class students. If you're in 8 or if you're up until 11th class, we typically recommend taking Unacademy subscription. Hi Siddharth, hi, good evening students, a very warm welcome to JEE English and this lecture on gravitation. Stay tuned until the end to understand some of the most important topics around gravitation. Definitely, let me tell you, in today's lecture we are going to explore something really interesting. Of course, something we might have not thought about, but this exists everywhere in the world. Okay, and do not forget to apply Murli Live code to avail best discount on your subscription. So yes, do apply Murli Live coupon and get the best discount. Hi Shivam Dikshit, hi Shivam, hi, how are you guys? And guys, not only that, students, you can split your payments into multiple parts using our pay in parts in-house feature, and we also have access to no cost EMI where you do not have to pay any interest on your easy monthly installments. So these are two interesting payment options that you want to check out while paying Unacademy subscription if you do not want to go through the hassle of paying all the fiat ones. We anyway have other payment modes like debit card, credit card, UPI on Unacademy. And students, if you're going for a 12-month subscription, it might be that you're typically a dropper or a long-term students. So yes, we recommend droppers and long-term students to take, even 12th class students to take a 12-month subscription. And what do we have for droppers, long-term students? We have dedicated droppers batch, we have crash courses, we have micro courses, we have national level test series going on, which is going to help you in a very short. Yes, of course, these are some of the amazing things that we have, and this all comes at a price of less than 2,900, a price of only 2,888. So be sure to apply Murli Live code, of course, to get the best discount on your subscription purchase. And students, this was all about plus subscription. We have something beyond plus subscription, that is iconic subscription. And what do you get on iconic subscription? You get personal touch and personal coaching, IITians and NITians, who will be able to exactly guide you through this path, who will be exactly be able to take you through this journey. You will be enjoying this journey, you'll be getting guidance from them, you'll be getting, like many like motivational sessions, workshops from IITians and NITians who have previously cleared this exams, and who will be able to exactly take you through this journey without any, without any hurdles, but in a very efficient way. And they will be able to inform you what you need to do and what you need not do during your JEE break. And yes, students, also it comes with study planner and many more features than plus. And this comes at a price of 58,500 if you're going for a 12-month subscription. If you're going for a 24-month subscription, cost you 90,000. And of course, if you can afford it, this is one of the best things for your JEE Mains and JEE Advanced preparation. Be sure to apply Murli Live code to avail best discount, be it on your Unacademy subscription, plus subscription or iconic subscription or any of your program. And not to say, our team is also on iconic subscription. Now you can take your JEE preparation to the next level with our personal coaching, with our personal touch. We'll be conducting JEE workshops. We'll be giving out expert guidelines, study planners, and test analysis on JEE, in English. And yes, it's an iconic subscription program, and we have one of the best teams for your JEE Mains and JEE Advanced preparation. You can also start at an iconic subscription. So stay tuned and get your tips on time, and be regular to the classes if you are on iconic subscription, or even if you're on JEE English. That being said, students, never be afraid of what you know. What you know is the thing that you have to strengthen. Try to grasp as much knowledge as you want, because what you know is generally a drop. What everyone knows is generally a drop. What we don't know is as vast as a ocean. Something Newton has said, and definitely true. And when it comes to gravitation, you know what, there are many things that stand for JEE Mains and JEE Advanced preparation. We can be sure about things that we can learn, and that we can excel. And definitely do keep your dreams alive. Make sure you're not giving up anytime on your dreams. Stay motivated throughout the sessions, throughout your preparation. That helps you boost your rank and your performance. All right, let's get into this amazing lecture. So up until now, it was 2 point masses, or two distributed bodies, where all the okay, anyway, you need to first get started. And yeah, up until now you're dealing with point masses or two distributed bodies, in which case we took center of mass to be the place where the point masses are. Now let's say you have a point mass and you have a body, and where the mass is distributed uniformly or non-uniformly. I'll give you the hint for both. I'll take you through both of them. But now, just to try to understand how this is going to work. So yeah, a rod with linear mass distribution of mass m1 along length L is placed at a distance L from mass m2. The gravitational force on m2 by rod m1 is going to be how? Try it out, get started. Voice lag, I'll check it out. Come, we do a thing. Don't know if streaming is also fine. It'll be fine soon. It will be fine. If you have a voice lag, guys, it will be fine. Also, during your lecture series, if you are watching a live lecture or recorded lecture, and if you think it is too fast, you can slow it down. If you think too slow, you can speed it up. Make sure you're making use of those options while listening. And lag, guys, sometimes there would be a lag, be it in your chat, or be it the way you're watching the video. Okay, any guesses? What should be the answer? Just start guessing it. Be it whenever you're hearing me, start guessing it, and start working on it. Really interesting. You should know your mistakes, students. Learn from your mistakes. The most important thing is you learn from your. All right, move to the problem then. Okay, so here is the thing. So this is of length L, and it is at a distance L from mass m2. Okay, this if we have already done the gravitation, this is something some of you might know. So I can kind of say all the masses at the center of mass. That is why we call this as center of mass, and say uniform mass distribution. In that case, the center of mass is at a length L by 2 from this end if this rod's length is L. Isn't it? That means how much should be the gravitational force between both? Should be F is equal to, so G into M1 M2 divided by R square. How much is R? This is distance L, and this is like L by 2, so this is 3L by 2. This should be 3L by 2 whole square. That should be how much? 4 into G M1 M2 divided by 9L square, isn't it? So absolutely guys, this is not the way to go about it, because this is how it goes wrong. So make sure you are not doing this. This is only valid as long as we are not certain about whether the other mass is the point mass. This is absolutely the wrong way of doing it. Okay. Now this concept, you will come across even in electrostatics. If you attended electrostatics based lecture, the same kind of concept comes up. And there too, sometimes it's like, for a spherical body, it's fine. As long as it's not a spherical body, you cannot. Okay, let's move into this problem, understand how to work around this problem. It's a very interesting problem. Stay tuned. So in this case, what we are going to do is we are not going to, do that thing that would be completely false. What we need to do is we need to define a small element. Okay. Always notice that there would be like a small element, like a tiny mass of M1, a tiny piece of M1. Let's call this to be having a mass dm1, and it is placed at a distance, how much? X from M2. Now this is more accurate, this is more correct. This is actually the way to go about it. So let's say only one, generally we are only dealing with linear mass distribution in this case. So it is at a distance X from M2. Really simple. And how do I find out the mass of this small element? We need to multiply this, that small, let's say this small dm1 is of course because it has a small length, like distance dx. If you're wondering why not dl, you can also take it as dl. I say this, like because many students are like wondering many things. Many things will be cleared out in this session. Don't worry about it. For example, ring-based problems also will be done. And many times you might have noticed, even me or many of the like lecturers will be saying, yes, volume into density, but here we are going to deal with something known as like not, I wouldn't call it linear mass density, but something like linear mass density, which is nothing but lambda, which would be known as mass per unit length. Yeah, but before that, let me tell you guys, there might be many problems when you are working out, you are very certain, you've done it the correct way, you're getting confused what is going wrong. It's nothing guys, it's something to do with the math means the way we are doing the assumptions. It's not at all a problem, you're on the correct track many times, but don't get confused. That is what I'll be clarifying you along with the sessions and concept and problem sessions, because I used to face the same problem. I'll show you one such instances when we get into the problem, next problem. Okay, first of all, let's solve this interesting problem, and this is the basics. With this you'll understand. All right. So yeah, so we'll be defining something known as lambda, which is going to be how much? Which is going to be mass per unit length, which is nothing like something like linear mass density, but that is not a very mass per unit length, not unit mass per unit length, but rather mass per. Okay, so I too have noticed this issues, like many times I'm wondering what is going wrong. Am I wrong? No guys, that's because if you are taken the right kind of the way where you can get the answer, you'll get it. But don't worry about it. Rod based questions anyway are like standardized rod based linear mass distribution. So it's all along the length L. So can I say the mass m1 has been distributed along length L? So it's m1 divided by L is lambda, which is nothing but mass per unit length. Now can we say something like this? If this is true, we can also say that this mass dm1 is how much? dm1 is dependent upon dx. That is something like how you say volume into density. Instead I'll be saying length into mass per unit length. Okay. And length in this case is dx, and what is that? Lambda. Lambda is lambda. This both are like looks like x and x. Anyway, I hope you understood. Like lambda into this would be lambda dx. Okay, this will be substituting finally when we are doing the equation. What we are going to do, the next thing, going to write down gravitation equation. Gravitation equation. This is something that we need. What is gravitation equation for this mass dm1? Force of gravitation, it's going to be like g into dm1 into m2 divided by x, right? X is the distance between both. Now this is what? This is like a dfg, because this is because of the force due to the small elemental mass. But this entire thing is varying from where to where? From one end to another end, isn't it? Lambda, yeah, lambda. So yeah, from this end, which is at how much distance, guys? L as given to you in the question. Don't worry about it, it's not up to the scale. And from here to here, it's going to be like the rod's length is L. You remember the rod is of length L, so this would be how much? Okay, this is just force due to that small elemental mass. And if you understood this point, why are we doing this? If you're noticing it, for every small element, even though they have same masses, if you're thinking about dm1, dm2 somewhere over here, they have same masses, but they are at different distances from m2. I'm going to call, not dm, you can't call this as dm2, but something like dm dash, etc. It's going to be of the same mass, but the distance from this m2 is altogether different, like some x dash. Hence the gravitational force due to this elemental mass is different compared to gravitational force due to this elemental mass. Hence, if you have taken the small elemental mass and integrated it from one end to another end, D would be accurate. Okay, clear? Is this clear? Two elements have two different impact on gravitation, or two different impact in terms of gravitational force on M2. Hence, we cannot be taking the final mass to be at the center of. Alright, so we know the thing now. It's going to be from L. Okay, it's all given in your diagram this time. And it's going to be, and guys, let me tell you, this is one of the famous kind of questions. Let me do a thing for you. So this is 12. So we'll be doing one thing until the end. I'll be only dealing with lambda. I'll give you the reason. Okay, we'll be dealing with mass per unit length. Okay. Now the thing arises. What is df? Df. If I need to find the total gravitational force, not only due to this small element dx, which has mass dm1, but and at a distance x from it, but due to the this rod varying from length L from the mass m2 to 2L from mass. So we would be integrating the dfg. Finally find out the total force of gravitation, and that would be how much? This would be g into dm1 into m2 divided by x square, and this goes from L to 2L. Now comes the question. Okay, what are we going to get now? We are going to get something. Let's keep it as lambda. Try to understand that point. I'm going to change the value of what? dm1. Of course, we need to do it during our integration. This is the same equation. G into dm1 into m2 divided by x square, and we are going to substitute 1 dm1 is equal to dm. Okay, keep noticing. And generally, guys, try to work around the lambda. Later on, you can substitute the value of lambda, not at all a problem. So just keep it as like lambda into ex into some g always will come out, so you don't have to worry about it. It's a constant term. Here I can take out the g. In fact, even m2, because m2 is just a point mass, divided by. Now here comes the here comes the real question for many of you. What if this mass distribution was not uniform? One of the best examples why you cannot apply center of mass. Okay, if let's say the mass here was greater compared to the mass over here, then lambda function would be given to you. Something like lambda naught into x, something like that would be given to you in the exam while you're solving it, or during your model problems if you have seen any book. Okay, in that case you would find out the function, or you would substitute the given function in terms of f of x. Here it's a constant. Here f of x is constant, which is nothing but m by l, m1 by l. Okay. m1 by l. Correct. So that is it. But yeah, this is how you do it. If you are taken lambda naught into x, you can still work around it. Okay, take a problem and try to work around it and see the effect of gravitational force. Let me take out the the constant terms in this case. In this case, lambda is constant. If your lambda was not constant, you should be writing down the function, students. You should be writing down the function. Okay. Very important, huh? Because first question, first introductory generally seems easy. But later on, students stumble upon what's going on. I'm not sure, there's a function given to me, correct or not. Okay, so this would be g into m2 into lambda, and integration of dx x square is going to be minus 1 by x. And this goes from L to 12. Okay, substitute the value of L and 12. If you're wondering what happened to the negative sign is fine. Integration is working fine. Mathematics is fine. This is going to be like minus 1 by 12, which is half of L, minus of minus L, which is going to be 1 by L. If let's okay, FG is going to be how much? Fg is gravitational force applied by, in this case, Fg is the, let me write it down something. Fg is the gravitational force applied by the rod on the point mass m2, is coming out to be something like g into m2 into lambda divided by what? We have nothing, so g into m2 into lambda, that's it, right? We have to integrate it. This would be like 1 by L, just rearranging the term, 1 by L minus of 1 by 12. There it was minus 1 by 12 plus of 1 by L. So this would finally come out to be something like this. G would be G into M2. If I substitute the value of lambda, what was lambda's value? Going to be 1 divided by the length of. Okay, just substituting the value, getting something like M2 or M1 M2 divided by L into, this is 1 by L minus of 1 by 12, which is going to be 1 by 12, 1 minus of half. Okay, this would be 1 by 2. The final value of Fg is going to be G into M1 M2 divided by 2L square. Is the problem finished? Actually, the problem is finished according to what has been asked. Okay, but always and ever, don't miss out one thing. What has been asked? Okay, what has been asked to you? Oh yes, let me clarify this thing. So very important, sometimes this can be confusing while you're taking integration based problems. So that's the reason I'm explaining you, especially when it comes to distributed masses. So this Fg is the force applied by your mass m1, this rod m1 on the point mass m2, which is in which direction? It's in minus x direction. If I'm going to call this as positive x and this is lying on x axis, this is going to be, this is positive x, that means this is going to be negative x. So this would be written as y. And one more important concept around this is, if at all we are not talking about the force applied by M1 on M2 rather, but M2 applied on M1, which is again going to be an attractive force. Let's this time call it as Fg dash. That is going to be what? Negative of this. That's going to be in the plus I cap direction. Very important. Don't get confused during your exam. What has been asked, or even during your practice. Just be sure about it. What is happening in gravitation? Equal and opposite attractive forces between both. It's a combined mass anyway. G, M1, M2. So plus I cap would be there. Writing down. Okay. Rather, what I wanted to tell you is this will be minus of Fg dash. What is Fg dash in terms of vectors? Okay. Right now, up until now, we are just dealing with the magnitude. I generally recommend, first of all, finding out the magnitude and finding the easiest way, and then going to the vectors part, unless and explicitly it has been asked in I cap and j cap. Okay. Oh yes. So here lies the catch. What? Fg, and sorry, that is not Fg, but rather Fg dash. Fg and Fg dash. Fg and Fg dash should be in the opposite direction. What is the direction of Fg? Fg's direction is minus I cap. Clear? This should be clear. And this is minus Fg dash, so it's going to be plus I cap. Okay? Let's move on to the next problem. Then I believe this one should have been really clear. So yes guys, start guessing this problem. A point mass M2 is placed at the center of ring of radius r with mass M1 uniformly distributed throughout its circumference. Then the gravitational force applied by the point mass on the ring is out. Okay, if you are even little skeptical about this result, you can do the integration. You have to do the integration reverse way around. You have to take a small element over here and say that small element is lying at some distance from to take this as dm. The point mass M2 is placed at the center of a ring of radius r with mass M1 uniformly distributed throughout its circumference. Then the gravitational force applied by the point mass on the ring is how? Now comes the question, like, how do you work around these kind of problems? So, any guesses what should be the answer? Like, how do you move about this problem? It's in the middle of the ring. It can be a question, on the axis of the ring. So should we dive into this question? There are no reasons to not. So yes, this kind of questions. Okay, first of all, this is mass M2. This is R. This is the ring having radius R. Ring is like a whole ring, but a circle. Now, how do we work around these? Okay, one thing you need to understand is if it's a uniform charge distribution all along this ring, uniform mass distribution all along this ring, this all of the ring has a uniform mass distribution in it. Even if I take a small element, it would have a uniform mass distribution. It's going to be, first of all, this is the thing that you need to know. What is lambda? Lambda is equal to m divided by 2 pi r. But the first thing that you need to know, but in this question, that is not the first thing that you know. I'll tell you why. Okay, symmetrical to this, there lies another elemental mass. So if this has a mass dm1, there would be another such as mass we are talking about. There would be another such dm1 which would be applying force in the opposite direction of equal magnitude. If this was Fg, this would also be Fg, but in the negative direction. This is cancelled. You would always find such symmetrical elements all around this ring. Okay, you would always find such symmetrical elements all around this ring. So let's see even if there exists more symmetry. Take this point. This point should have something like, you know, fg in some direction. Okay, not exactly fg, maybe like, let's this time take it as f dash, and then there would be such symmetrical element nullifying this gravitation negative direction. So if you have seen all around this ring, there are many such elements, elements which would have a symmetrically opposite element, which would be cancelling out the force. I think if I have written this as like repulsive force, this is an attractive force due to this. This force is due to this, and similarly this force is due to this element. So it will always remain in equilibrium with net force equal to net gravitational force equal to 0. Hi Shivansh. No issues. We are going to get into the most important part of today's lecture. Okay, many times you'll be confused how to, you have solved the problem, you're getting negative and positive. What should you be doing? There lies the catch. Even in the PYQ session, I have seen, okay, in PYQ session, we'll be discussing one such similar problem, if possible today. But this question often comes up, what is going wrong? I'm doing the integration, I'm doing it the right way. Then someone comes and justifies, no, you're not supposed to do it that way. You're supposed to do it. That is not at all correct. What we were doing is correct. But yes, of course, you need to be cautious of the concept, and you need to, of course, this is an attractive force. Be sure of it. So, but the net force in this case is how much? 0. Be 0. Right. So there are always, you can see always there would be a symmetrical, mass which would be cancelling out the attractive force of another symmetry. Okay, opposite mass. Answer should have been. So placed, symmetrically around any mass distribution. So here lies the concept: placed symmetrically around placed symmetrically around which kind of mass distribution? Uniform mass distribution. Uniform mass distribution. Just a moment, guys. I'm having a look at your chat. Uniform mass distribution. What happens? Net force on a point mass tends. Net force on a point mass tends. Net G force on a point mass is okay. It can be anything. You will notice many such cases. Okay. Yeah, exactly. Equal and opposite force. Good. Punch. Okay. Now let's get into the next question. This is a very interesting question. What is happening is, earlier there was like a full ring. Now what we have is a semicircular ring. A semicircular ring, and what is happening in this case? You're moving from, what are they asking you in this case? You have a point mass at the center of the circle. If you complete the circle, there would be a center and there is a point mass. How do you find out gravitational force applied by the point mass on the ring? Even in the earlier case, if you have noticed, by the point mass on the ring. If you find out the other way around, it's in the negative direction. Okay, in this question you'll understand it. This was more efficient understanding it from the point, but still in this case as well, the force applied by the point mass on the ring is also 0. Okay, the force applied by the point mass on the ring is still 0. Negative of 0 is still 0. Okay, let's get into the next question. So now in this case, what is being asked? Anyone like whether it should be 0? Is this going to be 0? Yes? Yes or no? Is it lying symmetrically around a uniform mass distribution? No, very good. No, it's not going to be 0. Okay, It is lying around a uniform mass distribution, but it is not lying symmetrically. There is no symmetrical point which produces a opposite force. Okay, in such cases, in these kind of cases, you see this is a very popular problem, guys. This is a very popular field cube. This. Now let's take an angle to be like the. Why am I doing this? I'll tell you. Let's say I have a element over here. So what am I going to do is I'm going to calculate the force on the point mass due to this element. Okay, dm1, one element is there, and then take a negative direction. Okay, and take a negative direction. Okay, and similarly to the other side of the theta, let's say this is the, not probably theta, but let's say there lies a mass, elemental mass of the semicircular ring, which is also dm1, which is also applying some force in this direction. Sorry guys, I'm really sorry. I tend to do this. It's attractive force. We'll be doing the wrong one. This is going to be attractive. This is also going to be attractive. Now comes the question, due to both of them, you notice only one component would exist, the other component. One component along x-axis would cease to exist. Okay. Now, if this force, if you label this to be F, what is this? Symmetrical points, but this is not that exact opposite symmetrical points, but something is symmetrical about them, that they have theta and theta forming with x-axis, but one with that negative x-axis, one with the positive x-axis. So if this is going to be like f cos theta, this is also going to be f cos theta in the negative direction. So these both would cancel out. What is left over? In this case, only one thing is left over, that is, due to both of them, there would be addition of two forces, which is going to 2f sine. This is theta, so this force should be f sine. So twice of them, 2f sine. Okay, clear? So due to for every theta, there would be only 2f sine theta, or you can say from only f sine theta would exist. So which direction is this? This is in the positive y direction. If you take this to be positive y, okay, if you take this to be positive, then what is the direction? Okay, this is force on ohm by ohm. This is force on m2 by m1. Of course, for every there you have to add for different theta, for theta 1, theta 2, theta 3. You will keep adding the forces. Okay, net force is of course going to be theta 1 plus theta 2 plus theta 3. What do I mean is, like, there will be some 2f which is going to be constant. You'll eventually understand that thing, and you'll be adding that sine theta 1 to theta 2, so on up until where you'll be adding sine of if you're going from year to year, it's going to be sine of 90. But now comes the question, this is the force by whom on whom? This is force by the point mass. This force net is the force by point mass. This is the force on point mass. I'm really sorry. This is a force on point mass by the semicircular ring. Now, what is the force? Okay, what is the force? So which direction it is in? This is in positive y or plus j cap direction. Now if I had asked you what is the force Fg by the point mass on the ring, it's going to be the same magnitude as F net, but in negative j cap direction, negative y direction. Clear? Simple? Okay. Alright. Now let's move on to a solution. How do we do the mathematics? Rest is all mathematics. All you have to understand is, even given distributed mass case, how do you calculate the force? You can still do it the other way around. I'm more convenient with this. Even if you're convenient with one method, you can apply the other method. You can do the integration from year to year, taking the force on the point mass attractive this direction and work on it. It would come out to be this. Okay, but this is easier to right? This I said due to the ring on the point mass, it is some f sine theta 1, f sine 2, theta 2 up until that some 90 degrees or 180 degrees is added. That is going to be in plus j cap direction. The opposite force is going to be experienced by that semicircular ring due to the point mass m. It's going to be minus. Okay, clear? Alright. Now the thing is integration. When it comes to integration, there are two ways to go about it. One is mathematically there are two ways to go about it, like in terms of limits, etc. I'm going to take a small element d theta. This d theta at an angle what? Theta. Okay, d theta at an angle theta, and I'm going to say this is a small element. The small element has a mass dm1. Okay. Either you can go by 2f sine theta. If you go by 2f sine theta, your integration should be from year to year, which is going to be like 90 degrees, 0 to 90 degrees. Okay, let's do the 0 to 90 degrees thing and see if our answer is coming out to be wrong. If it's coming out to be wrong in terms of sign, you need to apply that small correction. Don't worry about it. Don't freak out. Don't assume that it is given the book from minus pi by 2 to pi by 2. That is when you'll get the answer. If you do minus pi by 2 to pi by 2, you won't even get the answer. Okay. So be sure about what you're doing. If you're confident about your concept, you'll eventually find the flaws when the kind of manipulations that is generally given. Don't at all worry about it. Move about the concept. That's the key. Alright, anyway, you'll get a negative sign. I think so. We will get a negative sign. Let's check it out. So what is the net force due to this element d theta, due to the element at an angle d theta, which is having a mass dm1? What is the at d theta, mass dm1? What is the force? It's going to be f sine theta, or you can take it out to be two such symmetrical thing. It's going to be 2f sine theta. Now for okay, easy. Now the next thing is either we can go from 0 to 90 degrees. What I am going to do is I am going to say only f sine theta y-axis component exists, and will not go from 0 to 90, but will go from 0 to 180. You'll definitely get the same kind of results. There wouldn't be any changes in this. For the entire ring, we need to go from 0 to, for integration I'm just stating, okay, 0 to 180 degrees. Alright, now comes the next thing. How do we find out the mass dm1? First of all, I told you, ever a question is given like this, what you need to do? You need to do something known as mass per unit length, some mass per unit length. How much is going to be this? This is going to be mass divided by the length of this ring, which is pi r. Mass per unit length only, but this is mass divided by, this is m1, okay, m1 divided by pi r, right, radius r, and it is only half of the ring, not 2 pi r, so only in the circumference it has. Okay, that's it, you know this thing, and we need to do one more thing. Okay, this we will try to express it in terms of r. Okay, If this is radius r, near about this will also be radius, right, over here. So what is going to be this small elemental length dl? dl can be written as r d theta. In the same way how you write down, L is equal to r theta. Similarly, we are stating for a small angle d theta with the same radial distance r and r, it's going to be r d theta. Now we know two things around it. One is lambda. The other one is dl. So we need to do to find out dm1. Find out dm1. I'm going to say something like this. dm1 is equal to lambda into dl. Is this correct? Yes. Mass per unit length into a small mass, that would give you the elemental mass. That is nothing but, in our case, it's going to be lambda into r d theta. Okay, simple. Oh, rest is a simple game now. Okay, understood? Easy, simple. Good. Okay, only f sin theta from 0 to 180 degrees instead of 2f sin theta from 0 to 90 degrees, same thing. Alright, so now we need to play the integration game. It's going to be theta, something like this. This is much lambda into r d theta, dm1. So what is your df? First of all, we need to write down the df. df is going to be, dfg is going to be m2 or g into dm1 into m2 divided by r square. For any of the element, what is the distance, students? Even you take an element over here at some different theta, distance is still going to be the radius of the ring, radius of the semicircle. Whatever, if you take an element over here, still distance is going to be how much? Going to be radius r. Okay, radius r of the ring. Easy. Okay. So to find out, before that, let me substitute the value of dm1. So that would be lambda into r d theta. Keep the lambda as it is. So it would be lambda into r into d theta into m2 divided by r square is going to be into g is going to be your dfg. R gets cancelled out. Finally, your dfg becomes. And very important thing, guys. Sorry. So plus of sine theta. This is dfg, but we are only concerned about the sine theta component. We cannot do it that way. This is the total force, but only we are worried about the y-axis component, which is going to be dfg of sine theta. Okay. We are not worried about everything, but only the sine theta component. Cos theta component gets cancelled out. Okay. Cos theta component gets cancelled out, only sine theta left over. Now you clearly got the idea what should be your net force be. Okay. Not dfg. dfg is the force, of course, but only one component exists. X-axis component is cancelled out. So dfgy is what we are concerned about, and this is going to be how much? G into lambda into rr gets cancelled out, so there would be an r on the denominator, into m2 is also a constant, into d theta sine theta. This needs to be integrated from 0 degrees to 180 degrees, 0 degrees to 180 degrees. Okay. Okay, shall we move on? Okay, we need to integrate this to find out the net force. Due to the net force, x-axis component is not valid. Okay, I'm just going to integrate this part, nothing else. Net force going to be integration of dfy, which is going to be integration of what did we have, g into, okay, just reordering the terms, g into lambda into m2 divided by r, only one r would be there, and into that of sin theta d theta. Instead of d theta sin theta, I'm writing it down as sin theta. So this is nothing but from which angle to which angle? 0 to pi or 0 to 180 degree. Same thing. So force net is going to be how much? It's going to be, let's take out the constant. Okay, so g into lambda into m2 divided by r, integration of sin theta d theta, which is going to be what? Minus of cos theta. Don't worry about it. That minus of cos theta should not be confusing you. Whatever you are doing is correct, guys. Don't get confused at that point in your exam. Why did I get minus of cos theta? Yeah, you are doing your integration correct, etc. That's not a point to worry about. Finally, find out the magnitude and substitute the value of the magnitude. Let me do a thing. I think we. This often happens, but you should be sure about the direction from your concepts, not from your derivation, your calculation rather than this. This is going to be minus of cos theta, and this cos theta, this often happens, I know, in different books, different angles will be chosen such that you exactly get it. Okay, and this would be what? G into lambda into m2 divided by r, and 1 minus of, sorry, minus 1 minus of minus 1. What is, why am I getting this? This is basically because minus cos theta is how much? If you take it from 0 to 180, it's going to be minus 1 minus of like cos of 180 minus cos 0. Okay, cos of 180 is how much? Don't worry about it, you're getting negative sign, etc. It's not at all important. If you do that, this thing will get cos of 180 degrees minus of cos of 0 degrees. It's going to be minus 1, which is going to be minus 2, of course. Don't try to justify it, guys. Don't try to justify it, students. That will just spoil your concept. This is what the math comes out to be. Let it be. Finally, the direction is a decision that you need to make. What you have understood is sin theta component only remains, y-axis component only remains, x-axis components gets cancelled out due to an equal and opposite force, and whatever remains you integrate it, you get something like 2 into g into lambda m2 by r. That is it. If you have done it from 0 to 90, still you will be getting cos 90 minus cos 0, which is going to be minus 1. Again, there will be a 2 there. So you will be getting a minus 2. Don't worry about it. That minus will come. But what you need to finally understand, this is a magnitude, this is an integration that you're doing to find out the magnitude. Shall we move on? I think we are running out of time, so I have another class. So F net is going to be minus, we are getting it to be minus. Now what I'm going to do is, there is minus 2 g into m into lambda divided by r. That's it. Divided by, much like consistent. But what I'm going to do is, we have derived this integration of dfy, which was in fact, what we have done is, according to our theory, what we have done should have been a plus. Why didn't we get the plus y? It's a problem with the integration. Don't worry about it. Don't try to find out the limits. Don't kind of train your brain saying that this should have been the answer. How am I getting this? What should be the limits? And everyone will have a different reason for it. Don't do that, miss. Right, there will be so many people coming out with too many different explanations for why you get a negative. That's not at all valid, guys. So this is, sorry, M2, guys. Everywhere it's M2, M2 students, it's all M2, 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 okay. And what is lambda? If you remember that lambda was M2 divided by pi r. So this would be pi r into r, that's going to be pi r square. This is just the magnitude. Okay, F net magnitude is 2g m1 m2 divided by pi r square. Okay, let's get into the question and make the sign accordingly. Okay, what has been asked in the question? The gravitational force applied by the point mass on the ring. And what have we calculated? Like in this case of sign, we have calculated the gravitational force applied by the ring on the point mass. So it should be in the opposite direction. This is by the ring on the point mass. If by the point mass on point mass on the ring, it's going to be exactly in the opposite direction. It's going to be minus j cap. Okay. Alright, guys, so your F net in our case, let me label it something like this. What are we deriving? We are deriving force on ring. Force on ring, when we are defining in the direction force on ring, will be in the minus j cap direction, magnitude equal to that of F net, which is going to be g m1 2g m1 m2 divided by pi r square and into minus j cap or j cap. It's going to be minus j cap. Okay, don't get confused, don't start justifying, don't spoil your concepts, don't make a mess around your concepts. Easy. All right, absolutely, Chandra, you can do that. Okay, we are doing full-fledged lectures. But anyway, we have run out of time. I have more interesting concepts for you to come up with amazing simulations that we'll take it up in the next class at the beginning, and then we'll move into many gravitational field-based concepts. But up until then, stay tuned. Check out Unacademy Combat. Enroll today, guys. Enroll today. It's going to be the most competitive, gamified. Yes, Chandra. Yes, you can absolutely crack JEE with this free lecture, students. It's not at all a problem. But if you are preparing very seriously, try to avail a subscription, try to avail a test series, try to be more sincere. Even if you are thinking, if you can't afford like something like a subscription or something, or if you're not ready to afford it, so do a thing, be regular to the lectures. For an example, electrostatics 25 lectures, you should be completing the 25 lectures, not leave it incomplete. If we are covering everything on JEE English, we aren't leaving anything uncovered, as far as I remember, as far as I think, there is no problem in electrostatics that you can solve. Like you cannot solve by attending those lectures. Those are like 25 lectures that you have. They are like full-fledged lectures for your JEE preparation. Of course, the difference is going to be different kind of model problems that you're going to get in subscription platform, test series, structured program, platform, and okay. All right, students, stay tuned and on Unacademy Combat. So yeah, be sure to participate in the Unacademy Combat, the most competitive gamified IIT JEE battle ever. Compete live and win lots of rewards and prizes on 6th of December. Do compete, guys. There are hundreds of Amazon vouchers waiting for you. There are like Apple iPad and Apple MacBook Air as the first prize, and also Apple EarPods. So be sure to compete live and win lots of rewards and prizes. Enroll today with Murli Live code and do it. Don't just keep it as a fun experience where you're just competing, but also as a learning experience. We anyway have batches dedicated for 11th class, 12th class, and 13th class. So enroll today. Okay, don't miss it out, and do not forget to apply Murli Live code and miss out this amazing opportunity. I think so, Chandradosh. It's up to you, right? Plus is like whatever you choose to do. Just do the test series. You can just do anything as you like. Okay. Share this video, like this video. Of course, it's a free of course lecture and a full length lecture on your JEE Mains and JEE Advanced topics. Today it was about gravitational force. Tomorrow it's going to be about a gravitational field. Next Tuesday. So stay tuned. The next lecture is going to happen on Tuesday at 6 p.m. And now at 7:30 we'll be getting started with the PYQ discussion. If you're attending Gravitation, you can understand electrostatics. First year students, don't worry about it, come and attend it. Anyway, I'm taking you to every basic concepts, and the PYQ session is not just about concepts but the way you should approach in your exams. How do you solve few problems within a seconds? It's a previous year question. If you have not done up until now whichever questions that we have dealt, like 90% of them were possible to be solved just by having a look at the options. So do attend the PYQ session. Right now we are dealing with JEE Main's problem. Here is where you have the best gift of solving the problems by just having a look at the problems. And do not forget to share the video, do not forget to like the video, and definitely do share it on your social media, WhatsApp, Telegram, Facebook groups, and on your Facebook page. Keep working hard to achieve your success. At the same time, work smart. Today attend the PYQ session to understand how you could have done it, and keep smiling. Ignore gossip, students, ignore gossip. And of course, Chandra wants to get in touch with the team. I'm not very sure. And do download Telegram app. If you don't have one, do download Telegram app and click on to this link which is available in the description box below. Yes, this link is available in the description box below. Just click on this link and you will get on to our JEE English Telegram channel, where you would get before time updates on every class conducted by our JEE English team. And be it even on Unacademy special learning app as special classes. And guys, I will be returning on Sunday. Of course, at 7:30 I'll be coming back again. But for first year 2022 aspirants, if you're not attending PYQ session, don't do that. That's of course for you as well. Of course, you're dealing with the tricks. Start getting accustomed to the tricks from now onwards, especially it's a Friday. Yeah. And on Sunday we have the vectors part 1, where we'll be not just covering vectors but also some topics around vectors which involves mechanics, etc. Some kind of problems that have previously asked based on your vectors, from 10 a.m. to 12:30 p.m. and of course the lecture will be continued on Monday. Be sure to attend it. It's a free of cost special class on vectors, and the second part would be happening on Monday. Don't miss it out. And students, not only that, units, dimensions and measurements has been completely completed. What have we done in this entire 4 session plus 1 model problem session? These are only 4 sessions. There would also be 1 model problem session. And guys, what do you need to do in this sessions? You need to of course attend these lectures and complete the model problem sessions. And why do you need to do that? It's the easiest topic for your JEE Mains and JEE Advanced preparation, and definitely you get a question in your JEE Mains and JEE Advanced. And not only that, it takes less time during your preparation, also during your exam. Also during exams is also into the easiest topic, and we have covered pretty much everything: units based problem, dimension analysis, measurements based problem, error analysis, least count analysis, everything on this 4+1 session. Be sure to attend it, be sure to enjoy it, and definitely we have discussed also PYQs. And if you don't have an Unacademy learning app, just do download it from your Google Play Store and App Store by typing in Unacademy on your your Google Play Store and App Store. And the first search result is going to be Unacademy learning app. Click on to this link and click on this install button. What do you get by clicking on Unacademy learning app install button? Okay, the install button, you'll be getting an Unacademy learning app, a handy app where you can get live notifications on classes conducted by your favorite educators. If you start following me, you'll get live notifications on the classes conducted by me. Not only that, guys, more importantly, you can also attend quizzes. Also, you can attend many, free of cost series. You can attend many more things on Unacademy learning app, including Unacademy Combat. And if you are, a plus subscription student, this is going to be a handy app for you for attending classes from anywhere and also testing. And guys, if you're looking for some champions tool, the best in class program for your JEE Mains and JEE Advanced preparation, it's going to be Unacademy subscription. What do we have on Unacademy subscription? We have the best educators across the nation on one platform, and where you can attend daily live interactive classes with them. That is going to be an Unacademy subscription. But not only that, you'll be attending all of these classes on a very attractive platform with polls and leaderboards, and where you will be getting live updates on your performance and your XP points, and you will be able to improve upon them. And you also get national level test series and analysis along with them. And every program is going to be a structured program. This way you will be able to maintain a proper schedule. You will be able to move systematically. What do you get in the structured program? You would get access to live doubt clearing sessions with the best educators across the nation. In every program, the 4th session is going to be a doubt clearing session. This also comes with quizzes and mega quizzes. So this could be the best thing that you can have for your JEE Mains and JEE Advanced preparation, especially to excel in your pursuit. And guys, click on the left hand top corner extension bar, choose plus, and then choose IIT JEE as your goal, and then hit on this get subscription button. And what do you get by hitting on this get subscription button? Access to both JEE Mains and JEE Advanced program. You can access as many programs as you want during your JEE Mains and JEE Advanced preparation. And students, this all comes at a very reasonable price of 2,100, less than 70 rupees a day. If you go for a 24-month subscription, be sure to apply Murli Live code to avail the best discount on your subscription purchase. And this is for a 24-month package. A 24-month package is typically meant for students. We recommend that to students from 8th to 11th class. All right, and guys, you can also split your payments into multiple parts using our pay in parts option. And also we have access to no cost EMI, where you do not have to pay any interest on your easy monthly installments. You don't have to pay any interest on your purchases. You can split your payments conveniently into multiple parts, and you don't have to go through the hassle of paying all the fee at once. We also have access to debit card, credit card, and UPI on Unacademy. And students, this all we recommend for droppers and long-term students. A 12-month subscription is something that we recommend for droppers and long-term students. And guys, this comes at a price of less than 2,900, only 2,888. And what do we have for droppers? Dedicated droppers batch, micro courses, crash courses, test series, national level test series, and what not more, actually I should say. We have many more things over here for your JEE Mains and JEE Advanced preparation. And yes, we can take you in that pace that is required. And do not forget to apply Murli Live code to avail the best discount on your subscription purchase. Sure to apply that. And this was about plus subscription, and there is something beyond known as iconic subscription that we provide on Unacademy. What do you get on iconic subscription? On iconic subscription, you get access to personal coaching from IITians and NITians who have previously completed this journey, who have previously cleared these exams, and who have previously have gone through all of these things. And they will be able to exactly guide you with the mistakes that you should not be doing while you're preparing for your JEE Mains and JEE Advanced. And of course, guys, of course, what do you get on this? You get dedicated workshops, personal coaching, study planners, test analysis on iconic subscription. And a 12-month subscription is going to cost you only 58,500, and a 24-month subscription is going to cost you 90,000. And be sure to apply Murli Live code to get the best discount, be it on your iconic subscription or plus subscription or any of the programs. And do not miss out the coupons, of course. And our JEE English team is also an iconic subscription team. Now you can take your JEE Mains and JEE Advanced preparation to next level with our JEE English team, that too in English. Now do it. You can approach us on iconic subscription. And of course, we keep conducting IIT JEE workshops. We give out expert guidelines, study planners, test analysis, etc. on iconic subscription. We have a really nice team with IITians and IITians and head of coaching institutes. So be sure to like, share, and subscribe to this video. Of course, do share it, because someone in need may get access to amazing videos, a full-fledged content for your JEE Mains and JEE Advanced preparation. And do not forget to also click on that bell notification button. See you in the next class at 7:30 p.m. students. Take care, stay safe, bye bye. Try to understand how to solve the problems, PYQ problems.